Sampling methods and its types. What is sampling? The process by which researchers select a representative subset or part of the total population that could be studied for their topics so that they will be able to draw conclusions about the entire population. There are two types of sampling method: probability sampling and non-probability sampling. Probability sampling is further divided into four types: simple random sampling, systematic sampling, stratified sampling, cluster sampling. Non-probability sampling is further divided into four types: convenience sampling, purposive sampling, snowball sampling, and Quota sampling. Let's study them in detail. What is probability sampling? Probability sampling involves random selection, allowing you to make strong statistical inferences about the whole group. What is simple random sampling? A simple random sample is a randomly selected subset of a population. In this sampling method, each member of the population has an exactly equal chance of being selected. This method is the most straightforward of all the probability sampling methods since it only involves a single random selection and requires little advanced knowledge about the population. Because it uses randomization, any research performed on this sample should have high internal and external validity. An example of a simple random sample would be the names of 25 employees being chosen out of a hat from a company of 250 employees. In this case, the population is all 250 employees and the sample is random because each employee has an equal chance of being chosen. When to use simple random sampling? Simple random sampling is used to make statistical inferences about a population. Simple random sampling works best if you have a lot of time and resources to conduct your study, or if you are studying a limited population that can easily be sampled. To use this method, there are some prerequisites. You have a complete list of every member of the population. You can contact or access each member of the population if they are selected. You have the time and resources to collect data from the necessary sample size. How to perform simple random sampling? There are 4 key steps to select a simple random sample. Step 1. Define the population. Step 2. Decide on the sample size. Step 3. Randomly select your sample. Step 4. Collect data from your sample. Let's study them in detail. Step 1. Define the population. Start by deciding on the population that you want to study. It's important to ensure that you have access to every individual member of the population so that you can collect data from all those who are selected for the sample. Step 2. Decide on the sample size. Next, you need to decide how large your sample size will be. Although larger samples provide more statistical certainty, they also cost more and require far more work. There are several potential ways to decide upon the size of your sample, but one of the simplest involves using a formula with your desired confidence interval and confidence level, estimated size of the population you are working with, and the standard deviation of whatever you want to measure in your population. The most common confidence interval and levels used are 0.05 and 0.95 respectively. Since you may not know the standard deviation of the population you are studying, you should choose a number high enough to account for a variety of possibilities such as 0.5. Step 3. Randomly select your sample. This can be done in one of the two ways: the lottery or random number method. In the lottery method, you choose a sample at random by drawing from a hat or by using a computer program that will simulate the same action. In the random number method, you assign every individual a number. By using a random number generator or random number tables, You then randomly pick a subset of the population. You can also use a random number function rand in Microsoft Excel to generate random numbers. Step 4. Collect data from your sample. Finally, you should collect data from your sample. To ensure the validity of your findings, you need to make sure every individual selected actually participates in your study. If some drop out or do not participate for reasons associated with the question that you are studying, this could bias your findings. For example, if young participants are systematically less likely to participate in your study, your findings might not be valid due to the underrepresentation of this group. Advantages of simple random sampling. One of the great advantages of simple random sampling method is that it needs only a minimum knowledge of the study group or population in advance. It is free from errors in classification. This is suitable for data analysis, which includes the use of inferential statistics. Simple random sampling is representative of the population. It is totally free from bias. The method is simple to use. It is very easy to assess the sampling error in this method. Disadvantages of simple random sampling. This method carries larger errors from the same sample size than that are found in stratified sampling. In simple random sampling, the selection of sample becomes impossible if the units or items are widely dispersed. One of the major disadvantages of simple random sampling method is that it cannot be employed where the units of the population are heterogeneous in nature. This method lacks the use of available knowledge concerning the population. Sometimes it is difficult to have a completely catalogued universe. It may be impossible to contact the cases which are very widely dispersed. Systematic sampling. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. From number 6 onwards, every 10th person on the list is selected. 6, 16, 26, 36 and so on. And you end up with a sample of 100 people. Stratified sampling. Stratified sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups called strata based on the relevant characteristics, example, gender, age range, income bracket, job role. For example, the company has 800 female employees and 200 male employees. You want to ensure that the sample reflects the gender balance of the company. So you sort the population into two strata based on gender. Then you use random sampling on age group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. Cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. For example, the company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. You don't have the capacity to travel to every office to collect your data. So you use random sampling to select 3 offices. These are your clusters. What is non-probability sampling? Non-probability sampling involves non-random selection based on convenience or other criteria allowing you to easily collect data. Convenience sampling. A convenience sample simply indicates the individuals who happen to be most accessible to the researcher. For example, you are researching opinions about student sports services in your university. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data. Purposive sampling. This type of sampling, also known as judgment sampling, involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. It is often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences. For example, you want to know more about the opinions and experiences of disabled students at your university. So you purposefully select a number of students with different sport needs in order to gather a varied range of data on their experiences with student services. Quota sampling. Quota sampling is a type of non-probability sampling method. This means that elements from the population are chosen on a non-random basis and all members of the population do not have an equal chance of being selected to be a part of the sample group. Snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have access to snowballs as you get in contact with more people. For example, you are researching experiences of homelessness in your city. Since there is no list of homeless people in the city, probability sampling isn't possible. You meet one person who agrees to participate in the research and she puts you in contact with other homeless people that she knows in the area. Difference between probability sampling and non-probability sampling. First, let's learn about the definition. A probability sampling is one in which each member of the population has an equal chance of being selected, while a non-probability sampling is one in which a particular member of the population being chosen is unknown. Alternative names. Probability sampling is also known as random sampling. On the other hand, non-probability sampling is also known as non-random sampling. Basis of selection. In probability sampling, selection is random, whereas in non-probability sampling, selection is arbitrary. Method. In probability sampling, objective method is used, while in non-probability sampling, subjective method is used. Inferences. In probability sampling, inference is statistical. On the other hand, in non-probability sampling, inference is analytical. Opportunity of selection. In probability sampling, opportunity of selection is fixed and known, while in non-probability sampling, opportunity of selection is not specified and unknown. Result. Probability sampling produces unbiased results, whereas non-probability sampling produces biased results. Hypothesis. In probability sampling, hypothesis is tested. On the other hand, in non-probability sampling, hypothesis is generated. Research. In probability sampling, the research is conclusive, while in non-probability sampling, the research is exploratory. Probability sampling method includes simple random sampling, systematic sampling, stratified sampling, and cluster sampling. On the other hand, non-probability sampling methods include convenience sampling, voluntary response sampling, purposive sampling, snowball sampling, and quota sampling. Difference between stratified sampling and cluster sampling. Definition. Stratified sampling is one in which the population is divided into homogeneous segments and then the sample is randomly taken from the segments. Whereas cluster sampling refers to a sampling method wherein the members of the population are selected at random from naturally occurring groups called cluster. Sample. In stratified sampling, the individuals are randomly selected from all the strata to constitute the sample. On the other hand, in cluster sampling, the sample is formed when all the individuals are taken from randomly selected clusters. Homogeneity. In stratified sampling, there is homogeneity within the group, whereas in the case of cluster sampling, the homogeneity is found between groups. Heterogeneity. In stratified sampling, heterogeneity occurs between groups, while in cluster sampling, heterogeneity occurs within groups. Bifurcation. When the sampling method adopted by the researcher is stratified, then the categories are imposed by him. On the other hand, in cluster sampling, the categories are naturally occurring groups. Objective. Stratified sampling aims at increasing precision and representation. On the other hand, in cluster sampling, objective is to reduce cost and improve efficiency. Selection of population elements. In the case of stratified sampling, the population elements are selected individually from each stratum, whereas in cluster sampling, population elements are selected in aggregate. Thank you for watching this video.